Okay, thank you all for coming to this event. I'm all excited about it. I've never seen this, and it should be really interesting. My name is Wes Ernsberger. I'm chair of the Green Sanctuary Committee that's part of this congregation here. And so my job today is simply to introduce Gay Canough, our speaker, and also Joe Kais. Gay is familiar to most of us. Tell you, she's been doing solar for a long time, and I think she's trained about half of the solar installers in New York State. So we're really glad to have Gay here with us. And Joe Kais is the founder and president of Heat Tech, and they do a lot of work right in the area here. And I'll tell you, Joe has this goal. I love it so much. I'm going to read it to you. My goal is to bring the trade I love so much back to the past, where quality, workmanship, and relationships mattered more than money. So thank you so much, Joe, for being here. Joe is a project engineer and will be telling us some things about recent advances in heat pump technology. So with that, Gay, you want to get started?
All right. All right, so I'm trying something new using my iPad for presentation, so hopefully it all goes smoothly. So this presentation is going to be, I'm going to cover some of the ways that we can get off of fossil fuel. And it's easier than you think. There's so much new stuff going on. It's really easy. So this is drill head being attacked by the solar person, the mighty caulk gun, the insulation person. Okay. And this is a little cartoon about, we're always looking down here and we should be looking up there for our energy. Let's stop with the power from below. There's a song about that, right? It's power from below. We've got to go for the power from above. So as you guys probably know, most of you guys know me, I'm a physicist gone bad. I used to do particle physics back in the day in the 80s, smashing up protons over at Fermilab in Chicago. That was loads of fun, but of course practical applications for that are fairly far in the future. There are some though. There's been great practical applications for that kind of work, like electricity and magnetism, which we used to think were two separate things. And then some physicists discovered they were the same thing. And that made all our electricity generation possible. I started ETM back in 1988, so that's how long we've been in business. We did aerospace consulting work in the beginning, and we got into solar energy in about 93, I guess that was. So this is our 27th year in business. I have a solar electric system on my house and also at my office on North Street. I have 9 employees now. And ETM stands for extraterrestrial materials. That's our original incorporated name. We were interested in using the resources of space to better life on Earth. And one of our main claims to fame in that business was the Lunar Prospector, which actually went to the moon in 1998 to look for water at the poles, which it found, which is a good thing, because if you want to do anything on the moon, you'd hate to have to bring all your water with you. That'd be heavy. In the early 90s, I got involved with NASA on space solar power, the idea of putting your solar array up in geosynchronous orbit where you get sun 24 hours a day. So this is one way of getting baseload solar power. However, we, at this point, don't really have very good space transportation infrastructure. Last time I checked, we were still thumbing a ride from the Russians to get to the space station. So we have to improve on our space transportation before we can build anything big. But we might eventually do that to get 24/7 solar power. One of the things I discovered in doing my studies with NASA was that at the moment, we don't need that because we have plenty of physical space on Earth to do solar power. So I'm not going to give you my solar power presentation. Many of you have heard that before. We're going to talk about a bunch of other things. And the thing that's driving my thoughts on this is climate change. Climate change is happening. This is the CO2 concentration since 1960, and it's going up and up and up and up, and it leads to more floods. We had a nice seminar at Binghamton University about the frequency of floods here. Yes, we know we have floods here. We live on 2 rivers. But what's happened is that the frequency of flooding in the last 15 years is a lot higher. You know, it's like we're getting probably twice as many floods in that period as compared to similar periods in the past. And those things are expensive. They are expensive as all get out. This is our favorite electrical supplier over in Johnson City that was underwater during the last flood. So that's expensive. These things, hurricanes, incredibly expensive. The federal government put in about $60 billion in aid to recover from Hurricane Sandy, which came right out of your tax dollar. And the funniest thing that happened during this recovery was when Governor Chris Christie of New Jersey, who is all, we don't need big government, we want the government out of our hair. Well, when his state got creamed by a hurricane, guess what? Help us, government, help us. So $60 billion later. So, how many? $60 billion. That was just the tax dollars. I mean, there was a lot of other money spent by insurance companies and states. So that was just the federal tax dollars that went into recovery from Hurricane Sandy. There's actually work going on now to encourage services like gas stations and such like to have backup power so that when there's the next disaster, they can be prepared. We'll see how that works. So it turns out that this climate change thing is being driven in large part by burning fossil fuel. More than half of our electricity is generated by burning stuff, and that includes, you know, coal, natural gas, oil, and all those things put CO2 in the air. And we are just ramping that up just so fast it'd make your head spin. It's really scary. And I feel for our kids who are going to have to deal with this mess much more than we do now. So we need to get off of fossil fuel. We really need to do that. How hard is it? Well, here's my little summary of the path to getting off. First of all, reduce your load. Energy efficiency. You know, I have people call me up all the time and they're using 30,000 kilowatt hours a year and they want a solar array to power that. And I said, well, okay, that's a 25 kilowatt solar array, and it's 50 feet long by 100 feet wide. It's going to take up your whole yard. Now what you could do instead is reduce your load. And there's a lot of ways to do that. First step, get an energy audit. That's free, get an energy audit. But Joe is going to tell us a little later about heat pumps, but there's other fun things. I mean, there's the easy things like getting the compact fluorescent or the LED light bulbs. There's the mighty caulk gun and insulation. There's little more things we don't think about as much, like driving an electric vehicle, or biking and walking more, or public transportation. I should put that in there. And then we can use renewable energy once we got our load reduced. I gave this presentation to the UU congregation in Albany, and we did it via video telecon. So that meant I did not have to drive for 2.5 hours, and I calculated how many pounds of CO2 I didn't have to emit by not driving. So we need to learn how to do that more. So here's some really easy things you can do to reduce your use of electricity. And I did these things in my house back in this would have been the early to mid 90s. I went from 25 kilowatt hours a day to 5, just with these things. So I went, back then it was only compact fluorescents, we didn't have LEDs yet. I got rid of all my incandescent bulbs. If you've got incandescent bulbs, get rid of them. I got an Energy Star refrigerator. My old refrigerator used 7 kilowatt hours a day. The new one uses 1.5. So when I got the lighting done, that cut my bill in half. And by the way, all these energy efficiency things save you money. So people are always wanting to save money. This is a really good way to do it. It cut my bill in half, and when I got rid of the old refrigerator, it cut my bill in half again. It's like I was stunned. Wow. Then I started line drying my clothes instead of using a dryer, And it's an ongoing battle to eliminate all the 24/7 loads. You know, all the things that are plugged in, like your iPads and your iPhones and your cell phones and they all got these little charger things, and got a lot more things are plugged in these days. So put them on a power strip and turn them off when you're not using them. This is my first solar energy appliance. Here is my Amish Woodworks drying rack for $30. Not too expensive. Okay, next, that free energy audit. Here's the website you can go to find out more about that, upgradeupstate.org. And there's a form to fill out, and then they'll give you a list of local energy auditors that can come and check out your house. If you see icicles, that means you have a problem. And I tell you, this year, because we had so much snow sitting around, I can't tell you how many icicles. I mean, the insulation people could make a whole living by just going around and looking at all the buildings with icicles and then leaving a little flyer in all their mailboxes because it's stunning. Icicles happen when heat rises up under the roof. It's not from the snow melting it from the top. It's from heat rising up, escaping from your roof and melting at the roof surface, and then the water is dripping down to the gutter and forming icicles. That's what icicles come from.
And rotting your woodwork.
And yeah, and it rots it can damage your roof too. I mean, it can damage your roof, it can damage your gutters. How many of you have seen icicles that are just huge things hanging off of gutters? I mean, those are damaging to your gutters. That house over there has R38 insulation in it, and it has no icicles whatsoever, and it never does. That's how do I know that? That's my house. And you know, getting that done is not expensive either. So that's, every time you see icicles, you know, picture dollar bills wafting up through your roof, because heat loss equals dollars lost through your roof. So we want to cut that out. So here's your weapons to reduce heat loss. The mighty caulk gun. Plug the leaks. Windows are, you know, windows themselves don't have very good R value, but maybe the bigger problem with windows is that the frame around the windows often is not sealed. You might get new windows, but did the contractor put insulation around the frame? The best kind of insulation is actually the spray foam kind that comes in the blue can that you get at Home Depot. And you spray that in, and that makes a very tight seal. So, but you know, when you have your windows done, you actually have to tell them to do that, and then you have to watch them and make sure they do it. I don't know why it's such an unknown thing. It's bizarre. And then, of course, insulation. And do the roof first. The roof is the spot where most of your heat's getting lost. If you can do the walls, that's all good, but sometimes it's hard to do. What we did in our house is when we got new siding, then we had the insulation put on the outside, and then the new siding over it. So that's one way to, you know, so you don't have to tear out your interior walls for the walls. Again, all these things are fairly inexpensive to do. I put this in here because our church here has brick walls on the exterior, and there's no insulation in much of or very little, I mean maybe there's an inch of insulation in the walls, but in order to do anything about it, we would have to take out interior walls, and a lot of our interior walls are cinder block walls, you know, and bricks on the outside. So this is a steel panel with basically a foam sandwich that you can put on the exterior of the wall, and you can buy it so that it looks like whatever you want it to look like. So if you wanted it to look like brick again, you could. So you know, it has a lot of different finishes on the outside to do. So that's just, I was thinking about that because we've been working on the church here to get it well insulated, and that's one of the things we could do to help our walls. I didn't put it in here, but the windows here, see we got all these big windows here. There are window quilts or insulating window shades that you can put on big windows like this, and those are R5. I mean, a typical window is only R1 or R2. We have done the first step. We've put on storm windows, which has helped a lot on our big windows here. But the window quilts, I have those in my house. You roll them up during the day, roll them down at night. They're easy to put on and easy to use. If you're building new, now you have an opportunity. And construction hasn't been going great guns here until maybe recently. There's starting to be a pickup in new construction. Now you have an opportunity to build a house that has a very low energy use. You can use passive solar design. You can build a tight, well-insulated house. People often ask, well, if I build a tight house, what do I do about fresh air? Well, you put in a heat exchanger to bring fresh air in. A heat exchanger exchanges the heat that's inside to the air coming in, so you don't lose all the heat in bringing in fresh air. When you just have a leaky house, you're always bringing in fresh air as whatever the temperature of the air is outside. So that's not as efficient. So build a tight, well-insulated house and orient the roof for solar panels, don't forget. So minimize gables and things that stick up out of the roof if you're intending on putting solar panels up there. And then please resist the urge to build a huge house. People get into their money, they get into their money, they're getting close to retirement, they got a nice pot of money, they go, oh, I'm gonna build my dream house. And they go out and they build a 4,000 square foot house, and then they can't understand why the energy cost is thousands of dollars a year. So resist the urge. I know it's hard. We are actually designing at ETM, we're designing a house made out of steel, made out of those foam steel panels. And we like steel. I mean, steel is a recyclable material. It's a very versatile material. It's very strong. You can build a house that has no interior posts if you want to. Like this room has no interior posts. You can make it all kinds of shapes that you want. We started with like a simple box, and now we're kind of up on a fancier one. So building new is a great opportunity for saving energy. This is a technology that is used mostly in commercial applications. It's basically solar siding. If you have a large south wall, you put this on, and it's got little holes in it, and there's a space behind it, so you heat up the air behind this panel, and then there's fans that move it into the building. So this is one step out from just passive gain, where you actually have an active component, a fan, moving the air into the building. And the company that founded this is in Buffalo, New York. It's called SolarWall. This is you might have seen this glass wall on the Fissions Federal Credit Union. When I first saw this, before I was in the solar biz, I wondered what it was, because I said, oh, they have a brick wall with windows in it, and then they have a glass wall in front of that. I'm like, huh, what's that for? Well, that's a trom wall, which is a similar idea to the siding, only you're doing direct gain from the light going through the glass, heating up the air behind it. You got a fan to pull the air into the building. So that's another thing you can build. Actually, you can retrofit that. They retrofitted, the building was already there, and they added that on if you have a big south wall. That's more of a commercial one, but I have seen residential trom walls also. Well, what about transportation? So it's one thing to deal with your own house, reduce your use, put in solar panels on your house, but there's these two other big sectors. There's transportation and heating. What are we going to do about those? Well, transportation, there's a variety of things we can do. At this point, we have an automobile culture, and our cities and streets are geared toward automobiles. They're not meant for bikes, they're not meant for walking. Here in Binghamton, there's actually quite a lot of effort to change that. There is a pedestrian and bicycle committee at the county level that works toward putting in bicycle trails. So a lot of these trails that you see going in are a result of literally a couple of guys who are really into it. One works for the county and one works for the Department of Transportation. And they submit grant proposals and grant proposals and grant proposals to get money to build trails. So join in with that. They could use more support from the public. But obviously walking, it's also good exercise. And using mass transit. again, we are reducing the availability of public transportation here in Broome County. What? We're reducing? That is one of the most efficient ways of moving people around, both from a perspective of money and reducing emissions, is mass transit or public transportation. So we should be increasing that, not reducing it. It also helps serve the community that doesn't have an automobile or can't afford to have an automobile. So we need to be improving that. Now here's another thing an individual can do, which is to do more bicycling. And you know, this is, I mean, walking is great if you live in an area where you can kind of walk to everything. If you're thinking about moving, that ought to be a consideration. If you're thinking about moving, like maybe you're getting ready to retire and you're thinking about where am I going to go, move to a place where all the services are close. Like right now I live near West Corners in Endicott. I can walk to the grocery store. I can walk to 2 different grocery stores from my house easily. I can walk to the post office. There's probably 5 restaurants I can walk to easily. You know, in other words, this stuff's all less than a mile away. So that's easy walking even for, you know, somebody like me who's getting a little older, a little more decrepit, but that's easy. So think about that if you're moving. And then bicycling is great because you can go a little farther without too much difficulty. I can ride down from West Corners. I can easily ride down to the Town Square Mall. There happens to be a nice rail trail that get me there for a part of the way. So, and there are places in this world like Amsterdam where bicycling is a big deal. Something like 30% of the workers actually bicycle all day, every day in Amsterdam. And they have these huge bicycle parking lots. And they have a lot more rules or signage on the road, you know, delineating here's bicycle lanes versus here's lanes for cars. They have special places for bicycles to go. I mean, it's a whole different culture than we have here. And think about it. It's cheaper. It's cheaper. Larry says, I think I'm going to buy myself another bicycle. I have a couple of them. And I think about it, I think, you know, you could buy a pretty fancy you could buy 3 or 4 pretty fancy bicycles before you would have spent as much as you spend on one automobile. You know, and then there's insurance and there's fuel costs with automobiles and there's insurance costs and all this stuff. So it's a lot cheaper. And even around here, now granted, we do have this time of the year where you really can't bicycle as much because it's too snowy and cold. But don't let the perfect be the enemy of the good. We got about 7 months out of the year where we can bicycle all day, every day around here. This is my my first hybrid vehicle. It has an electric motor here and a battery up here. So if you're feeling a little decrepit when you got to go up a hill, you just put your motor on, and this particular one gives you an assist. So you can set it to assist your pedaling, so you suddenly feel a lot stronger. It's great. If you want to have a little more protection, I've also tried out one of these things. It's an electric vehicle. It's called a GEM, and it can go about 25 miles on a charge. It goes about 25 miles an hour. It's great for tootling around Endicott. And I put doors and stuff on mine to keep the rain off. So we do have quite a lot of time in the year when you can use those kinds of things. And then there's electric vehicles, and there's starting to be more varieties of these. There's the less expensive ones like the Nissan Leaf. Does anybody have one of these? Does anybody have a Nissan Leaf or a Volt? Somebody around here in our group has. I know a lot of UUs have Prius, which is a hybrid. Nobody has a Tesla, huh? But the nice thing about the Tesla is it does have a big range. You can go, I think the biggest battery bank takes you 300 miles on a charge with the Tesla. And Elon Musk, who is one of the prime movers at Tesla, he's actually building a big battery factory, and he's also talking about building a solar panel factory, actually in Buffalo. We'll see if that goes through. The Volt is not 100% electric, so it's a hybrid. But it can drive on electricity for 30, 35 miles, and then, you know, then it'll run the gas engine. So my husband Larry here, he commutes every day from Endicott to Binghamton University. He could go all day, every day on only electricity, and the cost would be a lot less than gas, because the cost for your 12 kilowatt hours at 12 cents is $1.44. That gets you about 35 miles, as compared to your gas, which is, well, gas costs have been fluctuating quite a bit. It's going up again now. So what's it up to? $2.50 again. So it can save you money, and there's actually some tax credits for those as well. As far as I know, all these things have very well enclosed battery compartments. They have to for safety. The Tesla has all their batteries, they are all underneath and it's a pretty strong enclosure because they're heavy. They are lithium ion or nickel metal hydride batteries, so the cold does not affect those near as much as, say, lead acid batteries. In fact, lithium ions tend to work better in the cold. They have the opposite problem. They don't like to be hot. So, but no, I mean, it's just like anything else. They got to have a nice battery compartment to make sure that they're not exposed to the salt and slush on the road. So what about heating? So that's our other biggie. So we got ways of dealing with transportation and cutting our fossil fuel use there. But heating is another big part of our use. I mean, a lot of us have natural gas burning furnaces, right? Especially around here. I was stunned. I was listening to a presentation a couple weeks ago at the League of Women Voters, and the gentleman was giving us sort of a little history of the anti-fracking movement and how everything came to be. And he showed a slide, and I got to get this slide from him. He showed a slide of our usage of natural gas compared to how much we import. Well, we are addicts. We are addicts. I mean, we are using, it was like 3,700 units, whatever the units were, probably trillions of BTUs or something, versus 800 and some that we're importing, or that we're producing, I mean. So we're importing all the rest from Pennsylvania or Ohio or wherever. But we are, I believe it's the second biggest user of natural gas in the country here in New York, because, well, we have a heating load. So that's part of our trouble. So just like the drug trade, if you want the drug trade to dry up, you got to get rid of the users, right? So we are the users of the natural gas, and if we want to get rid of that, then we got to reduce our use. And how are we going to do that? So what we're going to do is we're going to do something different for heating. And I just threw this one in here because I did have a customer that wanted this. It's a central pellet stove. And then I found another customer of mine that actually has one of these in his house. It's a central pellet stove furnace. You know, it goes in place of his furnace. He has a great big hopper that he can put a ton of pellets in. And there's even discussion at Cornell about the possibility of delivering pellets for central pellet stoves. So that's a possibility. I actually have a pellet stove in my downstairs, a small one, to at least partially offset the use of natural gas. And then there's air source heat pumps and ground source heat pumps. So there's two kinds of air source and ground source. So at this point, I want to turn this over to Joe, and he's going to tell us a little bit about that. So Joe from Heat Tech.
Thank you, Gay. And thank you for having me, and I really appreciate and I'm honored to be asked by Jerry and Gay to show up here today. So first, a little bit about me. My name is Joe Kais again. I am the owner and founder of Heat Tech Heating, Air Conditioning, and Plumbing. And up till a couple years ago, I was a believer that we were going to be stuck with natural gas, and we were going to be stuck with fuel oil, and we were going to be stuck with propane for the rest of our lives. And I was against the idea of solar, or not the idea, I love the idea of solar, but I was against the idea that solar was ever going to be as efficient as we needed it to be to create the environments that we all love and need because we live in the Northeast. A couple years ago, the heat pump technology and the ground source heat pump technology has evolved to a new era by using inverter type technology and ECM drive motors to create a constant flow and a great environment for us to heat and cool in cold and warm climates. So the Mitsubishi is a brand that we kind of evolved into with air source heat pumps. And first, let's talk a little bit about what is an air source heat pump. An air source heat pump is a device that moves energy from one side to another by using the flow of refrigerant. The flow of refrigerant absorbs energy and it will allocate that to the areas in which we need. Our heat pump technology of yesteryear was capable of running down to 35 to 25 degrees Fahrenheit, meaning that below those temperatures, no matter what we did, we were immediately back onto fossil fuel, dependent on that once again. In today's world, we are capable of running down to 5 degrees Fahrenheit to the fullest BTU load that's available on any given piece of equipment. And below that, we're able to go to 13 below. And at 13 below zero, which of course this winter has tested that very much so for us, we drop a few bits of efficiency, meaning we lose a few BTUs below our normal rating. So if we're at 12,000 BTUs on a heat pump, we will deliver roughly 14,000 BTUs given the brand that you were using. 14,000, I should say. And at 5 degrees, we'll start losing that. So we'll never go below 12,000 BTUs at 13 below. So we will constantly have that evolution of heat. The advantages of this over ground source heat pumps is very simple. Ground source heat pumps are, though, a much more effective and more efficient way of providing this energy and this heat that we need. Ground source heat pumps are a lot more expensive to install. And part two of that is that I don't know too many contractors or too many designers in our area that know the hydrological or our water tables of what's beneath the ground. And a lot of studies are done, but things change. And one of the things that I've found by ground source heat pumps, which I also love, but I haven't adopted the idea that it's the end all be all yet, is that water tables move and change, and that heat that we're storing in the ground or that cooling we're storing in the ground changes based on the water table. That water table could take our energies. So like near a riverbed might not be a great idea to have this energy, but it can still work. Air source heat pumps, though, on the other hand, we basically put a small device on the side of a building. We can mount it high, keep it out of the floodplain. We can coexist it with solar. We could do multiple rooms. We can do multiple styles of fans. We can do a ductless split, which I have an example of here, which is a basic wall mount system that adapts to any area. There's multiple sizes. It has a noise level that's very much less than a human conversation. So the decibel ratings on this are almost non-existent. The outdoor condensing unit that you would mount on the side of the wall for a single zone system of this caliber is as quiet as, again, a human conversation. In fact, I have mine in my own home beneath my deck where I cook and entertain my guests, and it runs during the summer months while we're out there, and I have to actually check to see if the grass is moving underneath to see if it's working sometimes. So it's very quiet. So that's one less pollution that we didn't talk about, which is noise pollution that evolves with a lot of it. We eliminate that as well with these particular products. The other plus side to heat pump is that our heat pump technology is evolving. We're at the beginning of a trend. And the trend is that with Gay's expertise in our area, which I don't know too many people in the area that has her expertise in solar. Like you said, she's pretty much the innovator and the trainer of this to everybody around us who does this. The evolution is just what she said. It's basically that the more people that adapt this idea of using heat pump, air source heat pumps, the payback is always going to be greater. Ground source heat pumps, and I'm kind of using it as an example because we've all been trained and we've all been taught to believe that ground source is the end-all be-all to our problems. And I do believe that's the case. But it's years behind where we need it to be versus our air source heat pumps. Air source heat pumps let's use it for an example, is I can put a single source system like this into any home for about $3,000 to $5,000. A geothermal system could be $35,000, depending. So your payback is much greater. The other part is that I did a study on my own home. The Mitsubishi, again, is the brand that I adapted to naturally because they're the innovator, they're the beginning, they're the ones that brought it to America first, and they're the ones that are still here. And they still only have a fifth, and you can correct me on this, but I believe a fifth of the market share in the United States currently. Everything else is fossil fuel. So right now, even with those costs, what they are, which are still relatively inexpensive, a fossil fuel furnace will cost you $5,000 to put in. The more people that put in these heat pumps, the lower the price is going to be. And the more people that adapt that to solar, the lower solar is going to be, as we've already seen. Because and Gay, I think you could tell, solar used to be very expensive, and I think the prices have dropped quite a bit, correct?
Oh, yeah.
So the question is, and let me reiterate it, is that do you have to put more of these into a single house? In some applications, we do have to put several units in a house. So Gay mentioned a 4,000 square foot home. Some people have that fine wine taste. They want to have the biggest home, and those applications, yes, we definitely have to put several of them in, and it's based on taste. If you have, we try to put as least amount as possible in to make the system work. But if you have, an area where there's a lot of entertaining and you have multiple people, then yes, we're going to put one in that room. If you have an area where you spend a lot of time with your family, it makes sense to have one in that room. And then if there's areas where it's not, it will, and we just need to condition it, then we'll try to put one unit that centralizes that. So the question is that how does an air source heat pump grab heat from outside and reallocate that inside to heat the house? The answer is this. There is heat, even though it's cold outside. There is temperature, and there is heat in the air that it's able to be absorbed. On top of that, with inverter technology, which inverter is nothing more than a DC drive motor that you're able to ramp up and down, there's a natural friction of energy that's caused by the compressor, which is a small motor basically turning on and off to move the refrigerant around, and the friction of the refrigerant is created heat as well on top of that. So it removes that and brings it into the house, and through a very small coil, which I'll show you. Through this coil, as you can see, very small refrigerant coil, it will blow air through that and transfer the energy back into the room. So, and in the summer months, it does the opposite. We actually take the heat out of the room and remove it to the outside. Or in some of the bigger commercial systems, like for instance the Unitarian Church, you can go room by room for each classroom. You could put one of these units in every one. And right now there's 30 of us in here. We're all creating energy. We're delivering heat to this room. And that energy would then be drawn back through this unit and reallocated to an area where it's not being used right now, and deliver that heat to a room that just needs some conditioning. Not allowing it to go to the compressors, and not needing the solar at that point solar only to run the compressor to run the refrigerant, which makes it the efficiency that it is. So the question is this plugged into the grid as we're actually hoarding energy for this development? Yeah. So yes, we are. And so we do power this up to the electrical panel. And it is my understanding, and you can correct me if I'm wrong, but during this time of the year, obviously the sun's the furthest south, and so we lose some efficiency on the solar. Is that correct?
Well, here's the beauty of it. First of all, this thing uses a lot less electricity than, say, your electric resistance heating, okay? So it uses so little electricity that you now have the possibility of being able to generate that much electricity with a solar array on your home to run this thing. And we actually have a couple of customers doing this, so I know it's possible. But here's the other beauty. With electricity in New York, you're allowed to net meter, which means that you can generate excess solar electricity during the sunny times of year, and you accumulate credit kilowatt hour credit on your utility bill to apply to the cloudier times of year. So that means that you can actually have kilowatt hours to use for your air source heat pumps, even though you need the heating at the cloudier time of year. Now this is very different from my old rant was about solar hot water heating and a radiant floor, you know, to heat your house that way. And the problem with that was that you had to collect the heat during the time of year when you had very little sun. Whereas this way, because of net metering, you can collect the electricity credits during the sunny times of year to apply to your heating load. So that's really the beauty of this. And the fact that it's so efficient really makes that possible.
Okay, so the question is technology. How new is it? It's not very new. Europeans and the Japanese and the Koreans have been ahead of us on this for years, and it's a natural order of things. It seems as if in the heating and air conditioning business that over there they're ahead of us because they have much less ability to create power, so they're trying to constantly find ways to be more efficient, and so it's kind of starting to trend over our way now, thankfully. To give an example of power usage versus a normal heat pump, so an old-fashioned heat pump that is used very commonly in the middle states, the North Carolina, South Carolina, you might be 30 to 60 amps of electricity of power usage during the use of this system. Where a Mitsubishi in today's world, a lower end one will be between 7 to 15 on the smallest and up to 30 on a multi-zone system, which you asked about, which is the capability of residentially running, what is it, 8 units, Shane? 8 units inside of on a residentially, and commercially it's virtually endless. You can do room almost an entire large structure. So the question is that if you have a hot water boiler, what could you use to kind of eliminate the use of fossil fuel in your home? There are electric boilers that are made, but they are very, very high hogged energy products. They're very, I mean, the amperage on one's like, what, 180 or something. Yeah. It's very expensive to run. There is technology coming in future that will adapt to this Mitsubishi or other heat pump lines that will allow us to tie directly into your system. But it's not here, and it won't be here for a few years. But so what we've done is we try to, again, utilize the air sourcing as your primary, have the air conditioning as kind of a luxury of it, and then have the high, baseboard as a backup, kind of per se. So we hit a couple days this year where it was 24 below, at least at my home, and every heating system at that point was completely taxed, and that would be a source where that heat pump at that point's pretty much going to shut off, and you're going to need some kind of backup at that point anyways. So we do that, and of course ground source heat pump is a viable option as well for that type of installation. In fact, that's a better, if you want the whole gamut and want it all tied in with the solar and everything, that's the better way to go in that particular instance. There is incentives. They do seem to change on a monthly, weekly basis, but there is, and so if we catch it at the right time, sometimes there's a really great incentive, and other times it might be worth waiting for something to come through. So the question again is geothermal the same as a ground source heat pump? Yes, it is. It is. So again, the question is there a lot of mechanical moving parts, and what type of maintenance would be required in an air pump or air source heat pump and a humidity control? So both of those are great questions. Anything mechanical, whether you have geothermal, whether you have hydronics, whether you have anything, requires a certain amount of maintenance. The Mitsubishi or any brand air source heat pump, from what I've found, it's very minimal maintenance. You don't have to treat water. There's basically a condensate line allowing condensation, which will fill your next question. That needs to be cleaned, and the coils. I showed you the coils on the inside and the outside. When they get a little dirty, they lose efficiency. So it's just like doing general house cleaning. Just got to keep the coils cleaned, and that's pretty much it. The lifespan, warranty suggests 7 years, but I've done Mitsubishi units 25 years ago, 23 years ago that are still in the same buildings and they're still working. They haven't changed them. I would like them to upgrade them, but they're still there. So although the warranty suggests 7 years, it could very well be 20. And humidity, it is a natural source of air conditioning, the air conditioning mode. A true dehumidifier removes humidity and then sends it back out heated so that you don't notice the difference. An air conditioner, in some cases, like in my own home, I undersized my air conditioning on purpose for my basement level so that I can dehumidify. I could take the humidity out of the air. So it runs longer and allows for the humidity to naturally aspirate. So there is, in these particular units, a natural set point that you can set for dehumidifying on them. But it is not a true dehumidifier like you would buy from the store that you would roll down in there where it reheats the air and sends it back in.
If you're going to go solar, normally NYSERDA looks at your historical use and says you can only have a solar array that generates 110% of your load. However, if you know you're going to put an addition of something, some load in, all we have to do is fill out a little sheet saying how many kilowatt hours we think that thing is going to use. And then you can get a solar system that's bigger than would serve your historical load. So we've done that a lot because we've had customers that wanted to add air source heat pumps, or they wanted to add an electric vehicle, so they knew they were going, or even add an addition, they knew their load was going to be bigger than their historical use. So that is no problem.
I just wanted to add real quick to what Gabe was mentioning about the share loading and loading up the solar during the summer months. And getting your credits back in the winter months. There's a lot of studies on the internet in Vermont and Maine, which is very, if I'm wrong, please correct me, but it seems like Vermont and Maine and the New England states have really adapted and really fell into love with what the solar and the heat pump. So there's a lot of studies on the internet to basically look at. And of course you got to read through the good ones and the bad ones, because some of them, the negative ones, you got to remember, there's a lot of contractors in every area that were never really contractors. They were guys that see that that you could do well in this era of business, and they've left other careers to start over and kind of go out there and do things. So they're making mistakes. Geothermal is one of the biggest ones. I see carpenters and different contractors doing their own geothermal systems. They don't know the physics. They don't know the understanding of how to design and what they do. They rely on, and not that IRR or other suppliers aren't great at designing, because they are, but they're not doing the install. So, things get transposed and changed from their hands to whoever the end installation guy is. So a lot of that install bloopers, I call them, are usually, and negative research done on the internet is usually due to somebody that dealt with that person or those people. So,
okay, let's finish up here. I just got a couple more slides, and then we'll go back to any additional questions. Thank you, Joe. That was fascinating. Fascinating. I actually used to install ground source heat pumps, so I can tell you it's a pretty big task. Digging up people's yards. It's like being in the Army. You dig up their yard, you bury the tubing, and then you cover it back up. All right, well, so once you've gotten your loads reduced, then you can start thinking about renewable energy. And I'm just going to throw a couple things out here, because we're not going to go into all these in any kind of gory detail, but there is a big resource. Probably some of you have seen this slide before about the solar resource. There's a pretty big wind resource, and all these renewable resources are per year. Okay, so for example, the solar resource here is 100 times bigger than the forever supply of natural gas. The yearly supply, that solar resource. And that's just falling on land. Okay, so that's really big. Here's our world energy use over here. The solar resource is 1,400 times bigger than the world energy use. So we do have plenty of resource in the sun and the wind, and there's a smattering of other things like true geothermal, which means tap those hot waters down deep. They do that in Iceland quite a lot. Hydropower, which we use a lot of that in New York. Biomass, ocean thermal energy, which is another kind of how do you extract energy from the water of the ocean. So lots of different things. Small wind is something that a few people can do. It's not too big in New York because we just don't have a huge wind resource at 100 feet in New York, but out west there's a lot more of that going on. We have installed a few small wind systems here in New York. Probably a better idea is there are some big wind farms in New York that you can buy into. You know, you can actually buy electricity from them. So you can do that through NYSEG for some of them. The Black Oak Wind Farm is, I believe they got their permit finally, so they're going to build this. And they were putting the word out to people to buy into it. And I think Cornell is going to buy all the electricity from it. That's what I've heard. so that's a good thing to do. Micro hydro, people ask me about this occasionally. I've found very few sites where I can actually make this work, but it's a kind of a cool idea. You have a little water wheel, you put it in your stream, and you know, it turns your alternator and it makes electricity. So in order to make this work, you have to have a head times flow. In other words, the height the water's coming from to your wheel in feet times gallons per minute. If that's not 1,000 or greater, that's probably not worth developing as a resource. But there are a few places, and then you do have, sometimes you have to get a permit from the DEC to do that too. So I've installed one of those, one micro hydro. The solar industry, I just throw this up here. The industry is growing like topsy. We have 17.5 gigawatts installed in the United States right now. 40% growth. So I plugged this into my spreadsheet, this 40% growth. And you know, if we kept growing our solar installs at that rate, in less than 20 years, we could be powering 100% of the United States of America with solar. Less than 20 years. So that's where it's easier than you think comes in. If all we do is keep growing the way we've been growing, and this has been going on in the last 4 or 5 years, there's been years when it was 50%, there was a couple of years where it was 100%, you know, where we doubled the installs. If we doubled the number of installs, we'd be done in 10 years. Germany is still putting us to shame. They have over 36 gigawatts, so twice in the entire United States of America. But we're catching up. So that's good. The industry has created about 174,000 jobs. So just in the paper this morning, what was I reading? We're losing jobs in Binghamton. How are we going to create jobs? Well, let's get busy on the solar industry, on the heat pump industry. There's all these opportunities sitting there, and people are just playing with their lips. You know, come on, we got these opportunities. Okay, I did keep that. Solar power is not just for hippies. Walmart, the biggest industrial user of solar power in the United States. Walmart. We got Kohl's in that mix, Costco, Apple, IKEA, Macy's. All these are big companies that are covering their rooftops with solar. So, you know, if you thought it was just a silly notion that a few people are doing, you'd be wrong, because the big boys are doing it. And they're doing more and more of it. And why would they do it? Because it saves money. It saves money. You know, the cost of solar panels has dropped like a rock. 35 years ago, the cost of a solar cell was $76 a watt. Today, it is 74 cents. $76 to 74 cents.
How many years ago?
That was 35 years ago. So that is the power of mass production, pure and simple. Use more of it. Use more heat pumps, get more electric vehicles, the price of batteries goes down. Did you know that there is a $14 million battery research facility at Binghamton University? Just started. Pretty cool. So here we have that. We have, you know, we have a lot of great stuff going on right here. We just got to capitalize on it and quit looking at it like, oh well, that won't work. Oh well, I don't know. Yeah. Why is Binghamton in the state it's in? Because, and why is Ithaca second only to New York City in job creation? Ithaca, a little tiny town in the middle of nowhere. Really? Come on. We should be right up there here in Binghamton. Why is that? Well, we need to be more progressive, and we need to change our attitude. So there's my little chart of $76 a watt up here. 74 cents. The installed cost has gone down a lot too. It's gone down probably a factor 2, somewhere a factor 2 to 3 in the last 5 years, the installed cost of a system. And what we're working on now with the solarized programs that I mentioned earlier is to reduce the soft costs. So to reduce the amount of cost in things like getting customers and getting permits, those kinds of things. In New York, okay, so I said Germany had 36 gigawatts. California has 8.5 gigawatts of solar. New York, 0.338. The governor, who we feel is pretty ambitious, 3 gigawatts in 8 years. That's his goal. If we want to serve 40% of New York's need with solar, we need 150 gigawatts of solar if we want to serve 40% of the need. So I call this pussyfooting around. That's what we're doing in New York. Well, you know, the governor's been great. I mean, he has pushed forward a lot on solar, and that's really wonderful. We just need to be doing more. So Solarize is one way of doing that. We're doing locally. This is going to be our motto for the next Solarize program. Resistance is futile. You will be solarized. But we want to do this because here's the cost of getting a customer in the United States. Actually, that's probably the low end. It's $3,500 to $5,000 per customer. To get a customer, well, what does that mean? That means we got to advertise, we got to educate, we have to send salespeople out, we have to send salespeople out again. I mean, all this stuff costs money, right? In Germany, it's $350. Why? Because they know what solar is. They see it all day, every day. So, you know, you don't have to spend as much money and time in advertising to get your next customer. So that's one of the things the Solarize programs help with. And Solarize programs are all about holding lots of workshops, getting people educated, getting people to sign up for a bulk purchase, you know, for a special price and that kind of thing. We did one last year here. We did Broome and Tioga. I worked on one in Tompkins County, and there's going to be another one here in Broome and Tioga and some of the other counties around us. So stay tuned for that. It's easier than ever to, and I have to say this applies to the heating and air stuff as well as solar. There's always financing available for these things, so you don't have to expend a lot of money up front. You can get a home improvement loan for any of those things, for heating and air and for solar, or we have a few special things for solar. You guys probably have some special financing as well.
Yes.
So that makes it really easy. And I mean, these are some real payments that some of my solar customers are paying. And think about this a minute. Your smartphone probably costs more than some of these numbers, right? Per month, right? So this is getting very affordable. All right, so I'm gonna end there, and we'll go to any other question. Okay, so what should we do with Windsor, who thinks that natural gas is the only thing? Oh, the townships that want to secede from New York and join Pennsylvania. Well, in my mind, one of the most powerful things to do is to have more people using solar energy. Because I'm selling it. Who's going to believe me, right? But if you have, the more people you have that are doing it, the more data you have showing that it works. There's nothing more powerful than when someone comes, and we're doing some video testimonials with some of our customers, so we can put those up, to say, look here. And John, is he still here? No, he's famous for saying, it's cloudy out, and yet my meter's turning backward. I'm selling solar electricity back to the utility. So, or one of my customers earlier this week at a meeting, he says, holy smokes, it's the middle of the winter and I generated 27 kilowatt hours for my solar array. And they're all excited. So seeing it work is one of the best ways of getting more people to adopt it. And that is one of the purposes of the Solarize programs. And now as far as downsides go, well, now another thing is that if you're talking about sort of collecting information, this is something that I'm trying to get NICEA to do, collecting the information of what is really going on out there. I did have one slide, I kind of skipped by it real quick, of all of the solar companies. So these are all solar companies. These represent jobs being created. This is a very powerful thing for politicians to really look at what is the job creation situation, and it's pretty big. And there's real data on this from SEIA, the Solar Energy Industries Association. So that's another good way.
The other thing is that natural gas will be flowing through all these suburban areas, and they're going to put pipelines in, and that's great. But remember, it's still an entity. It's a single source entity that will own the system. They're going to sell you the system. They're going to charge you for meters. And with solar and any type of independent technology, whether it's microgeneration, whether it's solar, whether it's heat pump with solar, you're in control of your own destiny. You are your own energy provider, and you're not relying on that particular person to deal with that. So I don't have propane at my house because I can't stand having that propane tank own me. I like to buy my fuel wherever I can get my fuel, the best price and reasonable price. So it'd be solar. I'm going to have a micro generator, and I'm going to have solar, and I'm going to be by myself.
There are downsides to everything. Every technology we do, we have to worry about pollution, for example. Anytime you manufacture something, you have pollution issues. And if you buy stuff made in a country that has less strict regulations than we do, then you may have more pollution issues. You may have worker treatment issues. So there's those kinds of things. And solar cells are made of silicon, so that material is a benign material. I mean, silicon is silicon dioxide is sand. But if you use silane gas, well, that's a hazardous material while it's being manufactured. So you better be making that in a factory that has good safety things in place. And then anytime you got to dispose of something, what I would love to see is that anything we manufacture, there's a plan for how to recycle it. That would be so good. There are some things like that, like lead acid batteries have to be recycled. Yeah, I just saw a cool presentation, we're about out of time here. I saw a cool presentation last week about a place that was going to take wood chips or different kind of biomass and make synthetic gas, which he didn't say exactly what all was in it, but it's like hydrogen-rich gas. It's cleaner than, say, natural gas, and do that. So biomass is inherently carbon neutral because you had to grow the stuff, which took up carbon. And then if you burn it, you're putting it back out. So you're just exchanging it back and forth. So, but yeah, there's downsides to everything. And anytime you make anything, you got to pay attention to that. There's actually one solar company that makes solar cells out of cadmium telluride, which is not a benign material. And so they take back every single thing they make. That's in their plan. Every single panel, it goes back to them to recycle it.